Marco already introduced the main idea that I will be talking about is unity beyond multiplicity. This is something which should be obvious. It is not obvious in general. When we look at Grothendieck, at the many mathematical works of Grothendieck, we will see a gigantic diversity. It is really a multifarious giant, finally taking the last name of the conference. So this diversity is fundamental in Grothendieck, but beyond the diversity, as Marco insisted several times, unity is fundamental. So I will insist on that unity, going very quickly in a very synthetic way over his many contributions. So I will present first one way of looking at this unity, what I have been calling in the last 10 years, the RTSK models constructed in the spirit of Grothendieck, in which we can think about mathematics as a ship, and then a moving ship around history, and beyond that moving ship around history, we can take what are the global sections, the invariants of those knowledge, and that gives us a more or less fair interpretation of the dynamics of mathematics between variation and invariance. I will present very briefly that model that I have been constructing in the last 10 years, and what may be more interesting for you is the use of that model to insist on that very simple but very profound idea of unity behind the diversity. You see, of course, the incredible diversity of Grothendieck in his historical development from his PhD thesis to the final works of the 1980s, which were really an outstanding construction of new mathematics. And if we look at all the different themes, we can perhaps have the sense of diversity without unity. But the unity is also not only a methodological and philosophical important perspective, as Marco was saying, but it's also a mathematical unity. That mathematical unity comes very clearly from the very beginning, answering to Marco's question, to Marco's first question, that category theory is really necessary to understand Grothendieck. Without category theory, one cannot understand Grothendieck, and we cannot do mimic the mathematics of Grothendieck without category theory. That would be a very bad perspective. So we will look at this diversity from this very simple model, which is inspired by the same Grothendieck. So the idea is extremely simple. It's a very simple idea, but I think it's a good idea that mathematics should be understood as a ship, in which we have in the bottom space what is the technical mathematics, which are proofs, definitions, theorems, examples, and beyond those theorems, examples, and technical constructions, we have ideas. The ideas are the fibers which are projected on the technical constructions. So there is a back and forth between what is technical in mathematics and the ideas which are behind the technicity, which is philosophy. Going back and forth between them gives you a shift between a global upper space and the bottom space. That is a folding and unfolding of ideas, in which you have at the bottom the theorems, the ideas which are folded onto the technical constructions, and then going upwards, the technical constructions are unfolded onto general ideas. This back and forth between the ideas and the constructions can be taught as a shift. And if you take that seriously, in a sense, I will not insist in here for now. It can be done in the questions afterwards if you want. If you take that seriously as a shift, that is a local homeomorphism, then you can see that the upper space and the bottom space correspond to important philosophical problems, like the problems of Leibniz and Peirce, to understand philosophy and mathematics. If instead of looking at one shift, which will be something like this, in which we have the bottom space of mathematics and the upper space of ideas of philosophy, we begin to look at many shifts at the same time. We look at many shifts at the same time, and all those shifts are interpreted over time. When appears the time, then you have the mathematical phenomenology of the understanding of mathematics as a phenomenology, which is the dynamic, developed dynamically over time. In the bottom, you take a model of time. One good way is to take a Kripke model for intuitionists, in which you have a tree in which you have the notion of future, and then you have a good notion of time at the bottom, and over any instant of the time, then you have moments of knowledge. Beyond those moments of knowledge, then you have possibly connections between those moments of knowledge that would be global sections. So if you take the three of these together, you obtain the topos of shifts of a Kripke model, in which you have three levels. The first level is the level of history, the development of mathematics. The second level is the level of phenomenology, in which you have the ideas which are connected. And then beyond that, you can have a space of global sections, of invariances beyond time and beyond the phenomenology of each construction of mathematics that would be called the metaphysics between Guillemets in the topos. So we have three levels, three simple levels, already with this simple idea that if we understand mathematics as a shift, then we can introduce three things which are fundamental for the mathematical knowledge: history, phenomenology, and metaphysics, with technical levels and philosophical levels at the same time. Then you can ramify this over a Riemann surface. I will not insist on that. These are ideas that I have to try to ramify mathematics to culture. For the moment, I will not insist about that. These are examples of ramifications of mathematics around general moments of culture. I will now insist only on Grothendieck. So let me say in the next half hour, before having some kind of time for questions, let me show you some of the first drawings that I made some 10 years ago around Grothendieck, to try to understand Grothendieck from this with this perspective of unity beyond multiplicity. So in the bottom part, these are the first drawings, so they are in Spanish. You will excuse me about that, but I did want to conserve, in a sense, the first hand drawings that I made, that I think are more interesting than just the constructions with tech, which are done afterwards. In the bottom part, you can see history developing, the Kripke model for the history of the main Grothendieck contributions. We will see 12 fundamental contributions by Grothendieck, in which you have the main fundamental ideas at the level of the shifts over each of these times. In the period of his PhD thesis in Nancy, 1944, 1949 to 1953, you have the invention of the nuclear spaces. Invention of the nuclear spaces. There you have the nuclear spaces, in which you have at the bottom space some techniques, and in the fibers of idea you have some fundamental ideas of Grothendieck, which will be clearly repeated afterwards in all his life. So from the very beginning, I think that the roots, the germs of his unity are extremely clear in his PhD thesis. When And Grothendieck is inventing the nuclear spaces in order to axiomatize the good behavior of the spaces of holomorphic functions, or the good behavior of the spaces of distributions. He's looking for some kind of smoothness between those spaces, and he tries to characterize them in several ways. In a local way, using a family of seminorms, which are telescopic seminorms, or in a global way, more synthetic way, in which the space is nuclear, if and only if, when you take the nuclear product of that space with another locally convex space, the projective and the injective constructions are equivalent. So there is a synthetic global way of understanding the nuclear space, using the category of all the locally convex topological vector spaces, or locally using different families of seminorms. So from the very beginning, already in Grothendieck, there is a very clear going back and forth between the local and the global, between the analytical description and the synthetic description. And he's looking already from the very beginning at the category of all the spaces. He doesn't use the word category yet, because 1949 is still too young for the emergence of category theory. But 2 years, 3 years later, he will begin to use the term of category theory. But he is looking at all the collection from many structural points of view. That already is a category theoretic perspective in which he's interested and at looking at the smoothness of the constructions beyond the universal characteristics. So that happens already in his PhD thesis. And afterwards, in his incredible work of the résumé des espaces nucléaires in Sao Paulo, his incredible article where he's beginning to invent the theory of fine Banach spaces, he introduces then this beautiful, again, construction in which he begins to think in a very systematic way, as Grothendieck will insist all the time. He inverts all the time one problem. His idea of inversion of one problem in a category of constructions will be repeated again and again and again all the time from the very beginning. So the main question was to characterize the Hilbert spaces inside the category of Banach spaces. He does that. He produces the answer, showing that any Hilbert space can be a projection of a continuous of a space of continuous functions and an injection in a space of measurable functions. He inverts the perspective which was known before him. So this is a beautiful, incredible text in which I think is perhaps the best way to begin to learn to read Grothendieck specifically. I always do this to my students. Read these 100 pages, style Grothendieck, very dense, but very clearly written text in which he is working at the same time in topology, order structures, and algebraic structures. And you will see how Grothendieck is really thinking at the same time. He's thinking in a structural, universal way with a lot of the capacity of looking at the good smoothness properties of a general category. So that already is very, very clear from the very beginning. In his PhD thesis and his resume of Sao Paulo, he already is answering to Marco's question. You cannot escape category theory if you are to understand Grothendieck. And that continues all the way. Then afterwards, when he begins his postdoc in Kansas with the construction of the Tohoku, there you have like the emergence, the gigantic emergence of category theory, the invention of abelian categories, and the proof that in abelian categories with enough actions, you have enough injectives in the category, and with that you can show that the cohomology is a general, specific construction related to the iterated functors. There the style of Grothendieck is already extremely clear. He's thinking directly there in category theory terms, with the development of the language and the ideas of category theory. In that moment is that many of the students of category theorists say that category theory in that moment comes to work really in mathematics, thanks to this wonderful construction of the postdoc in Kansas. But already this in a little later, 1 year later, already Grothendieck finds out this fantastic construction in which he proves the Riemann-Roch equation, the classical Riemann-Roch equation, the equilibrium between the dimension of meromorphic functions minus the dimension of analytic functions on a Riemann surface is related exactly to the genre of the genus of the surface. That he shows that if we think this in a general way, thinking in a category of coherent shifts, then we have almost a good relation between what is the Chern character and the homology, and there is a little obstruction. If you take a small movement around that little obstruction, then you obtain exactly the Riemann-Roch equation, and then you are seeing that he's thinking again on a shift on a complete way of a category, the category of all coherent shifts, which gives you the understanding of the local classical equation from a more general perspective. That general perspective gives you the units all the time. Generality is not done because you want just general nonsense. That's an absurd and ridiculous perspective of category theory. Category theory, of course, is not at all a general nonsense. It's a deep way of understanding mathematics, because you want to show up the unity of mathematics is one of the main questions. But in fact, you want to show something which is invisible, beyond the visible. This is one of the main themes in Grothendieck all the time. One of the main themes will be to try to look to a smoothness, looking at the general structure of the categories. You are interested in a smoothness, universal smoothness, thanks to the general constructions. But you are interested in showing what is in the bottom, in the deep bottom of our understanding. That's why he was very interested in mobility all the time. We have the testimony of John Tate that Grothendieck had always mobility on his bed and trying to read parts of mobility. So he's interested in this kind of general question also, which is fundamental for mathematics and fundamental for Grothendieck. What is beyond types? The types are just the surfaces. Beyond types, we have archetypes. Those archetypes are the fundamental things, where you get some unity beyond the multiplicity. So the unity beyond the multiplicity is not just a methodological or philosophical question, but it is at bottom a very deep technical mathematical question. You will get that unity, that multiplicity, thanks to these processes. You're interested in a smoothness and naturality instead of difference and artifacts. And you are interested in some sense in an integral calculus beyond some kind of differentiability. You're interested in some integrality beyond all that. And all that is obtained precisely with the techniques of Grothendieck. Grothendieck is inventing this kind of techniques to discover the unity which is beyond. So this duality between a discovery and the invention that Marco was presenting is fundamental in Grothendieck. He believes really that he is discovering a profound unity, but how? Inventing new techniques all the time to show that unity. So we have this kind of integral and differential calculus in a conceptual way. The category theory is a natural construction to understand the unity and beyond the multiplicity, the integrality beyond the differentiability. And that continues to happen all the time in the construction of the work of Grothendieck. His famous conference of 1958, where he invents, in an incredible sentence, he invents the whole program of his next 15 years, in which he has this incredible vision that to show the Bell conjectures, what he has to do is to produce an intersection of the theory of Galois and the theory of Riemann surfaces. And he invents then the étale constructions which correspond to this blending, this incredible blending of Galois and Riemann. He has that vision in 1958, and it's again a vision of a smoothness. He's inventing the smoothness techniques in order to solve discrete problems. The reason afterwards he will construct in the great period of the center in Paris. I was putting at some moment at the bottom of my slides the margins and the centers. Perhaps you can see here margin, the first margin when he's in Montpellier, the second margin when he is in Sao Paulo, the third margin when he is in Kansas. He is usually at the margins of the understanding of the world, except in the moment in which he is in Paris at the IHS, and there he is at the center of the world. The world comes to Grothendieck at that moment, and between those years in the Séminaire de Géométrie Algébrique at the IHS. There he invents this contraposition, also this beautiful contraposition between what is étale, corresponding to this intersections of first ideas of Galois and Riemann, and the étalé, which will respond more to the idea of a sheaf. Espace étalé in the French construction of the Cartan school is the idea of a sheaf, in which you have this deployed space, which is projected onto a more leveled space. At that moment, in between 58 and 64, a great vision in Marcos Panza was, the vision was important, the vision was fundamental in some moment, but the other part, which is absolutely fundamental, is the architectonics. The architectonics of Grothendieck is fantastic. He's not just this multifarious giant genius, but he is a builder. He works and works and works hours and hours and hours on mathematics for 10 years until he is more or less burned out. At the 70s, he is already at the level of invention and construction of inventing a new school of thinking mathematics, which is really outstanding. And one can, perhaps if one is looking for very, very simple but very profound distinctions between the Grothendieck, we can look at this pendulum, the pendulum between the étale and the étalé. The étale, the leveled C, and the tale, the shift. Just this single accent changes everything in Grothendieck. And the back and forth between the tale and the tal is one of the main and simple ways of understanding this unity beyond the multiplicity, which is clearly one of the forces in Grothendieck. 64 to 67, you have then the SDA, the invention of the schemes and the toposes. Colin McClarty will explain that with all care afterwards, the importance of the two of them beyond the very universes of Grothendieck. He was really interested in the construction, in the algebraic geometric constructions of mathematics to answer very concrete questions. This is very clear in Grothendieck when we read, and something that we should do often. When we read directly Grothendieck, we will see that he is always presenting a lot of examples, a lot of calculations. So when we say that Grothendieck is this gigantic, universal, abstract constructor, he was also extremely concrete constructor with a lot of calculations. In fact, who was saying that, I think it was the very Lovier. Lovier said that Grothendieck was the greatest calculator of our times when he was thinking about in the 60s. And the very Dieudonné also said in one moment that the only analysts which were at the level of a strong calculation as Grothendieck were Banach and Grothendieck. No more. Those were the great calculators of the century. So if we read directly Grothendieck, we will see that he has a lot of examples, a lot of calculations, which are extremely concrete. That's something important to take in our minds. So there is also this kind of continuity of unity between the concrete and the abstract, which is always a trademark of Grothendieck. Always from the very beginning, you go to the PhD thesis, lot of calculations, lot of concrete visions, and then afterwards, and then in the decade of the 1981 to 1991, that in that decade, the examples are fundamental for Grothendieck. Everything that Grothendieck is working on those times is constructed over very precise examples, over very precise Riemann surfaces, over very precise concrete number theoretic questions. It is not just abstract nonsense. It doesn't make any sense to talk about Grothendieck in that way. So this is also a fundamental question for Grothendieck. The back and forth between the local and the global, and the continuous and the discrete variations. Those are themes which are all the time universal, all the time continuous and softness properties which are driving him to many of his inventions. And he continues like that. In the 70s, and the work of Grothendieck in the 70s is less known, but there is a lot of things. There are a lot of things which are happening there. I call that another margin. It's another margin of his thought when he's retiring from the IHS and beginning to think in Montpellier. He has a lot of activity with a lot of students in that moment. And many of those activities will be fundamental for the next decade, which is well known, the decade between 1981 and 1991, in which he invents all these things are incredible inventions, the Annabellian geometry, in which he takes very seriously the behavior of the fundamental group. He extends the behavior of the fundamental group and tries to characterize the general geometrical structures which are captured by the fundamental group. He relates that to his work on complex variables. We will see at the end of this conference the presentation of Christian Ussel about the importance of complex variables for Grothendieck. He always had very concrete examples beyond his mind. So the Teichmüller theory in complex variables was one of the driving forces for him. And also, in those times, and driven by his studies in Montpellier with his students, he introduces the children drawings, which are a way of characterizing again Riemann surfaces by combinatorial properties, and he introduces the new ways of understanding topology. So always in a very systematic and very continuous way, he's interested in smooth properties of algebraic constructions. The smoothness beyond the discrete is something which always permanently drives in the back and forth between the local and the global, the local, which is the hierarchization, and the global, which are the actions, which are the ones which will provide a universal understanding of our mathematics. In that moment, in 1985-86, we have this Récolte Semaille, which appeared, on which Marco was standing his presentation, with his incredible reflection on mathematical creativity. For me, after Poincaré, L'Invention Mathématique is the greatest presentation of mathematical creativity ever written. No one has written better than Grothendieck about mathematical creativity. And then, finally, in the 30 years, from 1983 to 1991, we can still continue with our model, with our crypto model at the bottom. Then we have the main idea, critical ideas, the mathematical constructions, and then the fundamental ideas which are beyond these mathematical constructions. This is one of the greatest ideas ever constructed also in mathematics, the idea of derivators as a unifying perspective for homology and homotopy, and for looking at the general non-trivial intersection between abelian categories and toposes. All this driven by the category of sheaves which fibers which are abelian, or category of sheaves with fibers which are just sets. And then you can see that beyond all this, there are a lot of things which are repeated all the time. These kind of repetitions appear all the time. The unfolding and the folding between the étalé and the étal, the universality and naturality and the smoothness of all the constructions, the projections and injections between types and archetypes that exist all the time from the very beginning of his PhD thesis, and continues all the time from the very end at the derivatives. So there is a strong continuity, a strong unity in all the technical constructions, answering all the time to very general questions. So this is a way of utilizing the very tools of Grothendieck, sheaves, toposes, to apply a view of Grothendieck in a more or less systematic, unitary way. One thing that I want to insist is what is still open. We know at this moment more or less well what happened between 1949 and 1991. That makes us like 40 years, the 40 years of the known Grothendieck. But then afterwards, we have 30 years of the unknown Grothendieck. That makes at least of what is known for the people who have looked a little to the papers, 50,000 pages of Grothendieck, which are still to be evaluated, known, etc. Some people have said he was crazy. After 99, he was crazy. We shouldn't look at Grothendieck after 99. He was talking about the devil and I don't know, foolish things. That cannot be true. It's impossible. It's simply it's impossible, Marco, and we will have that discussion all the time. It's impossible that the multifarious giant and genius that he was for 40 years producing incredibly profound mathematics, after one moment he begins to do stupid things. It doesn't make sense. It doesn't make sense. It's completely absurd to think in that way. So that's something that the time will show us, that in fact he was a little, perhaps, a little crazy, but very, very little, very, very little crazy. I will accept that, but very little. I think that he was not at all crazy. He was always very coherent, and he was interested in a lot of things, and he was interested in things which are not interesting for us, but he was very coherent in his way. And it's just a common sense question. A person who does mathematics for 40 years in the most fantastic and imaginative way cannot stop. He must have done things which are incredibly beautiful here in this moment, in this paper. We will see. We hope that we will see that when the hairs permit to see what he wrote. But again, to finish, we can use the models, the DSK models. H is here for sheaf in Spanish. So the DSK models to look locally at parts of his output. For example, here you have the output of the last decade, the ideas which are connected by local and global sections, or we can try to look also to a more global perspective. The whole 40 years here are, in a sense, schematized through simple sheaves and simple fibers. And this only makes the point of unity more precise. The unity is there all the time, and we should be very careful to see that unity and to study it with care. So 2 references. I have a small book which is appearing on sheaf models for mathematical thoughts. I write in Spanish. I always have written in Spanish. I think that one should write in language, so I write in Spanish. And then there you have many examples of how the sheaves work at the 3 levels, or the level of sheaves, with many examples in Galois, Sheehan, Riemann, Cantor, Poincaré, Hilbert, Gödel, etc. In sheaves over Kripke models, in the topos of sheaves over Kripke, etc. And then you have like Riemann surfaces over these topos. I have not spoken about that. And essentially, perhaps more interesting for you, this thing, this Grothendieck guide. In the Grothendiecken spirit, it's a small guide to the mathematical work of Grothendieck and philosophical work of Grothendieck. Since it is Grothendiecken in spirit, it has 600 pages. So that's a small guide in Grothendieck, in which you go through all the main constructions, one by one, with all the care that I didn't have here. There in the book, I do it with all the care. I make the descriptions of all the texts, the synthesis of all the texts, from 1949, the first part. Second part is his main output in the EHS. And the third part, which I think is extremely important, the third part, the many very concrete constructions of the third phase, with his wonderful text, not only the Recoltes and my mentioned by Marco, but also the things in which he was a little crazy, like Le Desonge. He was a little crazy when he was talking about the God and things like that. He wasn't crazy. He wasn't crazy at all. Like Le Desonge, it's a book and of an incredible depth. We have to study it with care. And then I try to make all that together and make all the connections together in order to show in the last 150 pages of the book. I make the point of Marco in 150 pages that there is unity. There is unity beyond all the diversity in Grothendieck. So thanks.